Okay, now we're going to do something a little bit different. Remember we did the first ionization energy. This is specifically with this. So with this one, this is going to be energy losing 1 electron, which is what your chart's going to show, or the arrow diagrams. So again, these are my losers, and these are my gainers. Okay, so again, we kind of look at elements here. This is chlorine, and this one is, element 117. Really doesn't matter what it is. Now, if we're doing our trend, lose to gain high energy. So which one has the highest ionization energy? Well, it's going to be here. This one to this one, same thing, higher energy. This one to this one, higher energy. Okay, that would be your first ionization energy. Oops. I have a tendency to try to use that. That doesn't work too well. Erase all ink. And what we're going to do next is we're going to actually come back and we are going to do my second ionization energy. So, which one has highest second ionization energies? Well, you would have to kind of figure out where your highest increase is going to be. Let's say I want to go between my first and second ionization energy and the largest increase. So I want to know what the highest increase is between my first and second ionization energy. It is actually kind of simple, because you're going to look at that, the first part, and you're going to be talking about valence electrons. So let's go valence electron sequence, or my outermost electrons. Well, this one's going to be 1, 2, 3, 4, 5, 6, 7, 8. So what is my highest increase? Let's say I'm looking at 4 different elements, and one of them says this element here. And then maybe we'll put one here, one here, one here. Again, second ionization is the energy in losing 2 electrons. So which one would have the highest increase? It would be here. And you can look at it simply as you have 1 valence electron. So I would lose 1 to get to here, and then when I lose my second, this guy doesn't want to lose it. But again, do it based on valence electrons. So let's go ahead and delete this one. Let's go back to this one. Now let's say I want to go highest increase third to fourth ionization energy. Now again, you look at your valence electrons. 1, 2, 6, 7, 8. What's going to have the highest increase between your third and your fourth ionization energy? Well, again, let's say I have, let's go with elements actually. Got this, LEM, and let's see, let's go bromine. Well, which one's going to have the highest increase between your third and your fourth ionization energy? It's going to be the one with 3 valence electrons. That one's going to have the highest increase between your third to your fourth ionization energy. A lot of people have some problems with this because they seem to forget it's just based on ionization energy, and you have to make sure you look at the first one. Again, I really don't understand the problems with it. I mean, you basically have to just look at it and just make some common sense out of it. Let's say which one has my highest increase between, let's see, RB, and let's see, SR, SN, and let's go TE. I think that's where TE is. That's not where SN is. Well, again, you're going to look at your valence electrons. You got 1, 2, 3, 4, 5, 6, 7, 8. Let's say I want to know my highest increase between my first to second ionization energy. So let's say I want to do my first to second ionization energy. Which one's the highest? Well, RB. Why? 1 valence electron. Which one has the highest second to third? They don't get cutesy with these on here. So again, what do I look at? Which one has 2 valence electrons? SR. Same pattern. Let's go with SN. So what's going to be the highest one? Well, if you look at it, it's going to be 4th to 5th. Usually doesn't go that far, but again, showing the same pattern. Which one has the highest 4th to the 5th ionization energy? So that would basically be removing 4 electrons. Now let's go with TE. Well, that's 6. Highest increase? 6 to 7. Make this nice and simple, and it makes life a whole lot easier with this.